Hello everyone and welcome to this video. Today we'll be talking about one of the most important tools that every cybersecurity professional should know, Wireshark. So let's start with the basics. What is Wireshark? Wireshark is an open source network protocol analyzer that performs deep packet inspection across a wide range of protocols. It captures frames directly from network interface, dissects them according to their protocol structure, and presents the decoded data in a way that supports detailed forensic and diagnostic analysis. It works on Windows, macOS, and Linux, and it has become the industry standard for network troubleshooting and security analysis. What is its purpose in cybersecurity? Wireshark serves several critical purposes. It allows professionals to monitor network activity, detect suspicious or malicious behavior, investigate security incidents, and understand exactly how data threats move through a network. When IDS or CM tells you that something occurred, Wireshark allows you to determine precisely how it occurred at the byte level. Why is packet capture so important? Packet capture preserves a faithful record of what actually occurred on the network, whereas logs and alerts are interpretations generated by other systems that may be incomplete, misconfigured, or tampered with. Instead, a capture retains the communications it was transmitted. How does a cybersecurity professional use Wireshark?
Here are some examples of real use cases. In incident response, analysts examine captures to reconstruct attack sequences, identify lateral movement, and determine the scope of a compromise. In malware analysis, it is used to characterize command and control behavior, beaconing intervals and exfiltration patterns. In network forensics, it supports the extraction of transfer files, credentials transmitted in clear text, and other evidentiary artifacts. And in threat hunting, analysts use targeted display filters to proactively identify anomalous protocol behavior, unexpected destinations, or cover channels within baseline traffic.
Now that we understand what Wireshark is, let's define the core concepts you need to know to use it effectively. First, we have the network traffic. Network traffic is simply all the data moving across the network at any given moment. Every time you load a website, send an email, or stream a video, you generate network traffic. It's the constant flow of communication between devices. Second, we have packets. When data travels across the network, it isn't sent all at once. Instead, it's broken into small units called packets. Each packet contains a piece of the data, plus information about where it came from and where it's going. Then we have packet capture. Packet capture is the process of intercepting and recording those packets as they travel across the network. This is exactly what Wireshark does. It grabs a copy of the packets so you can examine them in detail, either leave or save for later analysis. Then we have protocols. A protocol is a set of rules that defines how devices communicate. Common examples include HTTP and HTTPS for web browsing, DNS for translating website names into addresses, and FTP for transferring files. Wireshark understands hundreds of protocols and can decode them for you. Then we have IP addresses. An IP address is a unique numerical label assigned to every device on a network. It tells the network where to deliver data and where it came from. In Wireshark, IP addresses help you identify the source and destination of every conversation. TCP and UDP. TCP and UDP are two of the most important transfer protocols. TCP, the Transmission Control Protocol, is reliable and connection-oriented. It makes sure every packet arrives correctly and in order, ideal for things like web pages, emails, and files transfers. UDP, the User Datagram Protocol, is faster but does not guarantee delivery. It is used when speed matters more than perfection, such as video streaming, online gaming, and voice calls. Then we have Network Interface Card, or NIC. A network interface card is the hardware component that connects a device to a network, either through an Ethernet cable or wirelessly through Wi-Fi. Wireshark captures traffic directly from the NIC, which is why choosing the correct interface is the first step in any capture. Finally, we have packet analysis. Packet analysis is the systematic examination of captured traffic to produce conclusions of investigative or operational value. It typically combines display filtering, stream reassembly, statistical profiling, and protocol-level inspection to move from raw capture to a defensible finding. This is the core in which Wireshark delivers its primary value. So first we have to open the browser, then just look for Wireshark. Select the download option, and here you have to select the one that matches your operating system. My case is Windows 11, so I'm just going to select the first, Windows X64. Now let's just wait for it to download. Okay, once downloaded, we're going to open the executable file. Next, noted, next, next. Okay, next, next. Ncap for me is already installed, but this usually shows a marked option install Ncap, so you can just leave it as default or unmark that option. Next. We're just going to leave it unmarked. Now we'll wait until the program is done installing. Okay, next. Finish.
Execute Wireshark. Here we have the toolbar section. Here we have the blue shark fin. What it does is that it starts a capture. We have the red square and it stops the capture. And here in the center, we have our available network interfaces. We have Ethernet for cable connection, Wi-Fi for wireless, and loopback for local traffic. We're gonna go with Wi-Fi for now. And here we have our three panes. The first one is called the packet list. Each line represents one capture packet. The columns shows important information: the packet number, the time, the source IP address, the destination IP address, the protocol, for example, TCP, UDP, or HTTP, and a summary of the packet content. This pane gives us a quick overview of all network activity. But then we have the middle pane that is called packet details, where we select any packet. For example, let's go with TCP, and we click on the arrows to expand each layer. For example, we can expand the internet protocol section to see the source and the destination IP address. Yeah, as you can see, we have it here. Or we could click on TCP section to see the port numbers, for example. But yeah, we have the third pane, is a packet bytes. This shows the raw data of the packet in hexadecimal format, and the same data as readable text on the right. Yeah. Well, this is useful for advanced analysis, and this is the Wireshark interface. Now my team will continue with packet capture.
Okay, so first of all, we're going to give a lesson on how to capture traffic. This is very easy actually in Wireshark. So first of all, we are going to choose where we want to scan the ports. Right now, we are not going to choose Ethernet because we don't have a direct connection with LAN, and we're going to choose the option that is Wi-Fi because we don't have adapter for low-back traffic here, so it's not recommendable Wi-Fi. And we're going to, if this does not happen, that is not very common to not to start capturing immediately. We're going to go here in capture, and we're going to go here in initiate. That is Control plus E. Then we are what we want to do here. So there are a lot of packets, but not everything that we want to scan. So that was we are going to use the filters. Sorry. Then we're going to go, I don't know, with Google and choose an option here. I have the MLB, the baseball leagues, and right now Wireshark should give me the packets that were necessary to go to this page. Then we will go back to Wireshark and put the DNS. Why the DNS? Because when we are going to just a web or a link, or PC is sending packets to a DNS, and the DNS is responding back to us by sending us the page. In this case, DNS is in private property and is owned by Google. So we're going to put the DNS, and then there are a lot of things that were open with Google. And one of here should be the MLB site. There is this MLB site. These are things here. This. When we open the page, a lot of MLB packets were open too. So we are going to now talk about the filters. What are the filters? Okay. So first of all, the DNS that we used to is to primarily search for packets that are with Google, with Farsila, something that is from online sources. The TCP, the TCP scan, is for saying things that maybe your PC has virus or is trying to connect, because the TCP what it basically does is to ensure that a connection was successful. So the TCP is just running around, making sure that something got connected to our PC. Most of this is important in cybersecurity too, because we can see there is a UDP flow or a DOS attack. What's the HTTP? What it does? Basically, I can use it now, I guess, because all of these links are HTTPS. That the S stands for secure. So what it basically does, I'm going to explain this quickly, is to search for encrypted traffic. The OPP is almost like the TCP, and it's important because we don't want to have a ODP flood. So on the IP point 8 DDR 8888 is the direction of the DNS of Google. It's directly from Google, not from another company. So if we want to search something that is directly from here, this is a good filter to use. The IP point SRC is mostly to use or to from packets that were sent from our computer, and the IP point IDDR, and this is our just to search everything except our router. So we are right now here in this code. This is not code. This to search all the packets except the ones that our router sent us. So this should be it.
Now, let's move on to basic packet analysis in Wireshark. Here I have captured network traffic and I will analyze one packet in detail. First, we can see the source IP address. This shows the device that sent the packet. For example, in this example, is in the screen as you can see. Then next we have the destination IP address. This tells us where the packet is going. In this case, once again, you can see the destination in the screen. Now let's identify the protocol used. Wireshark shows the protocol in the protocol column, and in this case the packet is using TCP, which stands for Transmission Control Protocol. The TCP is commonly used for the web communication, such as web browsing, emails, and file transfers. If we can expand the package details section, we can see additional information such as source and destination ports, sequence numbers, flags, packet length, and header information. Now, these details will help cybersecurity professionals understand how devices will communicate on a network. For example, a packet analyst can help identify deleterious connection, suspicious traffic, communication with malicious servers, and network attacks. This information is very useful in cyber defense because it always allows analysts to detect threats, investigate incidents, and monitor network activity in real time. Now, for the cybersecurity applications. Wireshark is mainly used in cybersecurity for many important tasks such as detecting suspicious traffic and troubleshooting network problems. Wireshark helps administrators discover issues like slow connections, packet loss, or failed communications between the devices. There's also the monitoring communications that I mentioned before, and in this case the organizations use it to observe network traffic and ensure that systems are communicating properly and securely. And one of the most important ones is the use of malware investigation, as security professionals can use and analyze malicious traffic to determine how malware communicates with external servers or how spreads through a network. Finally, Wireshark can help in identify unusual connections. For example, if a device connects to an unfamiliar external IP address, analysts can investigate whether the activity is legitimate or potentially dangerous. Overall, Wireshark is a powerful tool that helps cybersecurity professionals analyze traffic, detect threats, and protect networks from attacks. And that concludes our presentation. Thank you for watching.